In this video, we're going to talk about solving applications of quadratic equations by factoring. So let's take a look at the first example. The length of a rectangle is 2 less than twice the width. If the area is 84 feet squared, determine the dimensions. Well, we know the area of a rectangle is length times width. Now, I'm going to start off with W is equal to the width. Now, the length is in terms of the width, so twice the width, 2 less. So this is the length. So 2W minus 2 times W, and we know the area is 84. Distribute the W. And now I'm going to set this equation equal to 0. I'm going to factor out the GCF, which is 2. So now I'm going to set up my factor sum table on the side. So factors in negative 42 is sum is negative 1. Well, that is negative 7 and 6. So I'll rewrite. Set each factor that contains a variable equal to 0. Because a width cannot be negative, that eliminates this possibility. So we know the width is 7. Plug in 7 for W here. And that's 12. So I can conclude the following. The width of the rectangle is 7 feet. And the length is 12 feet. All right, let's take a look at the next example then. The height of a ball thrown upwards with an initial velocity of 128 feet per second from a height of 768 feet above the ground can be represented by this equation, where t is the number of seconds after the ball is thrown. What is the height of the ball after 5 seconds? Well, because time is represented by t, I'm going to have t equal to 5 here. And when I simplify, I get this. I get 1,008. So now let's write out what this means. After 5 seconds, the height of the ball is 1,008 feet above the ground. Okay, let's take a look at the next example then. So how long will it take for the ball to reach the ground? Well, when we talk about the ball reaching the ground, that means in this case S is 0. So I'm going to set this equation equal to 0. All right, so I'm going to factor out the greatest common factor. Because the leading coefficient is negative, I'm certainly going to take a negative out, but I can also factor out a 16 from every single term, and I'm left with this. Now, I want to find factors of negative 48 whose sum is negative 8. So let me write that factor sum table now. In this case, that's negative 12 and 4. So let's factor. Set each factor that contains a variable equal to 0. Well, since time cannot be negative, this solution is eliminated from possibility here. So let's write out what this means now. After 12 seconds, the ball will hit the ground.